The hybridization of solar plants with energy storage systems, known as BESS, is revolutionizing the renewable energy sector. But what exactly does solar hybridization mean? What are its challenges and, above all, its opportunities? In this video, we will explore how this integration is optimizing renewable generation, enabling greater penetration of clean energy into the energy mix. We will also discuss the barriers we face and the prospects for the future. Stick around to the end because if you are considering implementing or improving your energy strategy, this video will give you the full picture. Solar hybridization consists of integrating BESS systems with solar power plants to operate in a coordinated manner. The goal? To store surplus energy and supply it at times of higher demand or higher prices. With this model, we achieve three major goals: improve plant efficiency, reduce the discharge of unused energy, and increase the flexibility of the power grid. Countries such as Australia, the United States, and Spain have already implemented this technology with impressive results. However, hybridization is not without technical challenges that must be overcome to ensure its success. First, the intermittency of solar generation. Although BESS helps mitigate this, advanced control systems must be implemented to optimize battery charging and discharging. Second, battery degradation. Charging and discharging cycles reduce their useful life, increasing replacement costs. Designing operating strategies that minimize this degradation is key. Finally, integration with the power grid. In regions with high penetration of distributed generation, hybrid systems face synchronization and voltage and frequency management challenges. Rules and regulations are one of the biggest obstacles to solar hybridization. Why? Because the rules vary greatly from country to country. First, the lack of regulatory standardization creates uncertainty for investors. Second, grid connection requirements, especially in markets such as the Iberian market, can limit operational flexibility. And third, insufficient incentives mean that many projects cannot fully cover their costs. But it's not all challenges. Solar hybridization presents opportunities that we cannot ignore. First, energy arbitrage. Storing energy when prices are low and selling it during peak demand maximizes operators' revenues. In addition, it contributes directly to decarbonization by enabling greater integration of renewable energy and reducing the need for fossil fuel-based backup generation. It also opens the door to participate in markets for flexibility and ancillary services, generating additional revenues and improving grid stability. By 2030, more than 30% of solar plants worldwide are projected to integrate some form of storage. Tools such as Homer Energy and the use of artificial intelligence are driving this trend, allowing the operation of hybrid systems to be optimized. Despite this, cost reduction and improved efficiency of BESS will remain essential to unlock the true potential of this technology. Solar hybridization is not just a trend, it is a strategic opportunity to transform the way we generate and manage energy. If you are interested in exploring how this technology can benefit your business or project, contact me on LinkedIn for consulting or customized training. And don't forget to subscribe to the channel for more content and to continue learning about BESS systems.